In previous video, we studied how seller can maximize her revenue by choosing an optimal reserve price. But in this video, we are going to focus on welfare maximizing or efficient market. From the previous quiz, you can find that the auction can yield higher revenue to the seller than posting a fixed price if a reserve price is appropriately employed. But a reserve price may prevent an efficient allocation. If a market is efficient, then it allocates the item to the buyer with the highest value, right? That maximize the sum of the payoffs. So if bidders bid lower than a reserve price, then the seller retains the item, although the bidder's value might be higher than the seller's value. So that is not efficient. Sometimes a planner concerns efficiency rather than maximizing its own revenue. So for instance, governments allocate public houses or 5G spectrum and so on. In such cases, privatization may fail as private firms are to maximize their own revenue rather than the social welfare. So the question is, which selling mechanism is good for efficiency? Please recall that in transferable utility environment, efficiency is measured the welfare, which is the sum of players' expected payoff. First, we consider a fixed price system, and we want to choose a price that maximizes welfare. Each buyer has uniform distribution function. Suppose we set zero price. In the case, first comer will take the item no matter what her value is. So we have to choose some positive price to find a buyer who has a higher value. So given a price, we are going to try to find a welfare. So if first buyer's value is higher than the price, then first buyer will buy that item. So that's the situation. So X1 should be somewhere between P1 and the highest value, which is 1. And in that case, the welfare is the buyer 1's value, X1. And there is some possibility buyer 2, second buyer, will take the item. If first buyer is not going to buy the item, so first buyer's value is lower than the price P, but the second buyer's value X2 is higher than the P. In that case, X2 is realized as the welfare, social welfare, right? So this first integration is over X1. X1 should be between 0 and P, but X2 should be between P and 1, right? And we have this same part here. This part and these parts are essentially same. We just changed the variable into Z, right? And this is just with property 1, but the other one is just coming out because this part is constant with respect to X1. So this is going to be a integration times f of p. So we have this another part, 1 plus f of p. And we assumed this is a uniform distribution function. So we just replace this small f, density function is 1, and the capital F is just a p, right? And we just solve this, and we have this function, right? So that means this welfare depends on the price the market is setting. So you can easily find just again the get the derivative and set that to be 0. And the welfare maximizing price is 1/3. All right. And plug this price into here. We have the maximized welfare in the fixed price system. That is just slightly below 0.6. Right. So that means a positive price helps the item to be allocated to the buyer with a higher value. So this is the first quiz. In a fixed price system, please compare the welfare maximizing price and the revenue maximizing price. Please also look at how much the welfare maximizing price improve the welfare. So here is a tip. So in previous slide, this welfare is a function of P, and welfare concerns buyer's true value. But when it concerns revenue, this pi, for each successful trade, the seller is going to take this price P. So we just concerns P instead of their true value x1 or x2. So what we have done so far is we can improve the welfare by setting welfare maximizing price. But it is still inefficient because all the buyer's value could be lower than the price with some positive probability. In that case, the seller still retains the item, and that is inefficient. So any positive price prevents an efficient allocation. If the planner knows the buyer's true value exactly, then it's easy. She can just give the item to the guy with the highest value, so the planner can allocate it efficiently. But the problem is here, buyer's value is their private information. Given that, how we can obtain an efficient allocation or efficient market? So the answer is the second price auction with no reserve price. So in equilibrium, all the buyers bid their value truthfully, and the buyer with the highest value wins the item. The payment from the winner to the seller doesn't change the welfare because the sum of the payoff is still the same. So now we are going to consider the welfare in the second price auction. So here we have two bidder or two buyer, and their valuations follow this distribution function. And an efficient allocation assigns the item to the one with the highest value. So our concern is the max of x1 and x2, right? So please recall that the order statistic, the max of two random variable, that is also a random variable, and that follows the product of each distribution function. So the welfare in the second price auction, actually that there's no price in the auctioneer, or the planner is going to set the reserve price 0. So that's the second price auction with the 0 reserve price. And that is just expected value of a max of two random variables, x1 and x2. So that is easy if you are familiar with this order statistic. And this is a new random variable. We can say that is realization is z. And this is the density function, and its cumulative distribution function is the product of f1 and f2, right? So this is the maximized welfare, and we can obtain that maximized welfare by second price auction with no reserve price. Okay, here is the last quiz. So please compare the efficient auction and optimal auction, and we'll discuss how much welfare will be lost if the item is sold by a revenue maximizing seller.